They built a robot so human, people thought there was a person inside. Last week, Chinese automaker XPeng unveiled something that broke the internet. A humanoid robot that walks like a runway model, talks like a human, and convinced half the internet it was fake. The skepticism was so intense that the CEO had to release a behind-the-scenes video, unzipping the robot's back on camera to prove it was real. This isn't Tesla, this isn't Boston Dynamics, this is a car company, and they just might have cracked the code to humanoid robots. By the end of this video, you'll understand why iron could change everything we thought we knew about the future of AI and robotics. Here's why this matters right now. We're in 2025, the year the humanoid robotics market is exploding beyond every projection. China alone recorded over 610 robotics investment deals in just the first 9 months of this year, with production costs plummeting below $10,000 per unit. Tesla's aiming for 100,000 Optimus robots by 2026. BYD wants 20,000. Agility Robotics has a factory pumping out 10,000 digit robots. But here's the thing. Most of them still move like machines. XPeng's Iron doesn't, and that changes the game entirely. November 5th, 2025. XPeng's AI Day in Guangzhou. More than 500 people packed into XPeng Science Park for what the company called Emergence. Their vision for physical AI. They unveiled 4 products. A new AI model, Robotaxis, flying cars, and then she walked out. A 5'10", 154-pound humanoid robot. Female form, synthetic skin, curved 3D display for a face, gliding across the stage with the grace of a fashion model. Her stride was smooth, her balance perfect, her movements unsettlingly human. The live audience was stunned, but online? Chaos. Tesla's robot can't even walk this smoothly, and there's no way this is real, one comment read. Definitely a person inside, said another. Within hours, skepticism flooded Chinese social media platforms like Douyin and Weibo, with over half of all comments questioning whether XPeng had pulled off an elaborate hoax. XPeng CEO He Xiaopeng had to step in. The next morning, he released a video, unedited, raw, walking viewers through Iron's design. He stood next to the robot. "If you were here in person, you'd hear the cooling fans," he said, pointing out the faint mechanical hum. Then came the proof. He showed Iron's hands, too small for human hands, with 22 degrees of freedom powered by the industry's smallest harmonic joints. He pointed to the ear-like indentations, actually microphone arrays designed to function like human hearing. And then, he asked his team to unzip the back of the robot on camera. Inside, a mechanical spine, bionic muscles, circuit boards, no human. "This truly leaves our robotics team both delighted and amused," he wrote on Weibo. "Some people just can't believe how fast the world is changing. So, how did they do it?" Let's break down what makes Iron the most human-like robot ever built. First, the skeleton. Unlike most humanoid robots that use rigid metal frames, Iron features a bio-inspired spine and synthetic muscles that stretch and contract like real human tissue. This gives it 82 degrees of freedom across the entire body. Think of degrees of freedom like joints you can move independently. Your shoulder? That's 3 degrees of freedom. Iron has 82. But here's the breakthrough. Passive degrees of freedom in the toes. CEO He Xiaopeng explained, "This is what gives Iron its light, gentle stride. The toes absorb shock on hard floors like concrete, helping it balance naturally. The robot can walk at about 6.5 feet per second while avoiding obstacles. And it learned this by watching thousands of hours of human walking footage, not through pre-programmed movements." The hands. 22 degrees of freedom in each hand, achieved using the industry's smallest harmonic joints to maintain true human-sized proportions. Iron can hold a small tool or lift a heavy box with equal precision. Then there's the skin. Full coverage, flexible synthetic skin that feels soft to the touch. The curved 3D head display creates a face that changes expressions while speaking. You can even customize the body type before purchase. Now, the brain. 3 Turing AI chips, 2,250 trillion operations per second. To put that in perspective, that's enough computing power to process images and sounds in real time, make decisions, and control 82 moving parts simultaneously. XPeng calls it their VLA 2.0 system, Vision Language Action. Think of it as 3 AI models working together. One sees the world, one understands language, and one controls movement. The system links what Iron sees directly to what it does next. It can answer questions, fold laundry, guide a visitor through a store, learn new tasks through observation. And here's something no other humanoid robot has: all solid-state batteries. This is the same next-gen battery technology automakers are racing to perfect for electric vehicles. Lighter, higher energy density, no overheating risk. Iron is the first humanoid robot in the world to use this technology. 310-6 XPeng's vice chairman Brian Gu said the company believes they started their humanoid robot program before Tesla. And looking at the movement fluidity, he might be right. So where is Iron actually going? First stop, service industries. XPeng says Iron will initially be deployed in reception areas, shopping assistance, and patrolling. Retail environments where the robot will greet customers, answer questions, and display new products. Think about it. Our entire world is built for humans. Every door handle, every staircase, every office desk. A robot that moves like a person can slip into these spaces far more naturally than wheeled robots or mechanical arms ever could. The first real-world partner? Baosteel, one of China's largest steel producers. They're deploying Iron to monitor equipment for wear and tear, detecting faults before breakdowns occur. Industrial inspection, repetitive control tasks. XPeng is also rolling out units inside their own company by the end of 2026 for reception and sales support roles. But the bigger vision: elderly care, hospitality, education, any industry where natural human-robot interaction is essential. Industry analyst Mei Jihua told the press, highly human-like AI robots have strong potential in the service industry. They can play key roles in elderly care, hospitality, and education, where natural human-robot interaction is essential. And XPeng isn't keeping this technology locked down. They've released the Iron SDK, a software development kit for global developers to build custom applications. Want to program Iron to do a specific warehouse task? Build an app for it. The goal? Mass production by the end of 2026. But let's pump the brakes for a second, because as impressive as Iron is, there are real concerns here. First, the data problem. To make robots truly intelligent, you need massive amounts of training data, human behavior data, movement data, interaction data. XPeng says they've built an embodied intelligence data factory in Guangzhou to address this. But who owns that data? Where does it come from? What about consent? XPeng did mention a fourth safety rule, preventing human privacy data from leaving the device. But in an era where data breaches happen constantly, that's a promise we've heard before. Then there's the jobs question. If Iron succeeds at scale, and companies like Tesla, BYD, and Agility Robotics are all racing toward tens of thousands of units per year, what happens to reception workers? Retail staff? Warehouse employees? The automation wave is accelerating faster than society can adapt, and there's still the teleoperation debate. Some skeptics online said, "I'll believe it once reviews confirm it's not teleoperated. Until then, I'm skeptical." Is Iron truly autonomous, or are there humans remotely controlling certain functions during demos? XPeng showed the internal mechanics, but full independent operation in complex scenarios. That's still to be proven. So where does this all lead? Here's the thing about XPeng, they're not just a robotics company. They're an EV maker. They build autonomous vehicles, flying cars, AI chips. And analyst Ma Jihua pointed out something fascinating. Building robots is much like making cars. Both rely on sensors, control systems, and intelligent algorithms. Level 4 autonomous vehicles are already advanced robots in essence. In other words, the next step could be real-world transformers. China's breakthroughs in embodied intelligence mark a rapid expansion of AI into the physical world. Whether it's smart vehicles, industrial robotic arms, or humanoid robots, the underlying systems share the same foundation of AI algorithms and computing power. Different intelligent forms are achieving cross-scenario synergy. Industry analyst Liu Dingding said, Iron demonstrates a level of dynamic coordination and embodied intelligence well above the current industry average. Its stability and biomechanical fluidity closely resemble that of a human, reflecting deep integration of perception, control, and algorithmic modeling. Translation: this isn't hype. This is a genuine technological leap, and with humanoid robot costs dropping below $10,000, production scaling into the hundreds of thousands, and commercial pilots accelerating across automotive, logistics, and consumer markets, the broader rollout starts in 2026. We're not talking about decades anymore. We're talking about next year. XPeng built a robot so real the world couldn't believe it. They gave it bones, muscles, skin, a brain that can learn. They made it walk like you and me, and now they're putting it to work. The question isn't whether humanoid robots are coming anymore, it's how fast they'll integrate into every corner of our lives. And companies like XPeng just prove that future is closer than we think. So here's my question for you. Would you trust a robot like Iron in your home, in your workplace? Leave your thoughts in the comments below. That's it for this one. Thanks for watching. Don't forget to subscribe, and I'll see you in the next video.